As you may have seen in Monday's plenary presentations, 1Spatial technology enables location master data management using automated rules to measure and improve data quality and to synchronize data and propagate updates between systems. Now this applies both for data internally within an organization, but also when matching data between organizations to cross-reference it or link it to the authoritative source and start to build semantic meaning between the data sets and infer new information. The 1Integrate rules engine is complemented by the Data Gateway portal, providing controlled access to authorized users to run rules on an easy-to-use portal for uploading data. And this can be used for a number of data automation use cases. So for example, it could be data validation, it could be data improvement and enhancement, such as propagating and linking to multiple networks, or it could be data acceptance and ingest of supply chain data. Here's an example of a data improvement process that can be achieved using rules. Here we have two networks which represent either different networks or different representations and structure of the same network. When new data comes in, now this could either be information that changes the network, so new sections, splits of existing bits of network, reshapes, or else it could be things that reference that network, such as accident locations or surface quality reports, signage, asset locations, or even near real-time information such as traffic conditions. And we can create rules that can be used to automatically receive this data and propagate the changes to update the network or to reference the new assets against the networks. And that can make use of LRS and dynamic segmentation capabilities of 1Integrate if needed. This is a location master data management architecture using this approach. Here we've got a central enterprise store of data, but this might only be one of many different sources, each mastering a different aspect of the same real-world assets. At the top, Data Gateway is providing cloud access to rules-based apps. So for example, we might have network integration for propagating network changes through the system. We might have receipt and validation of ecology reports. General asset data supply chain integration, and that represents essentially any sort of data supply chain coming up from data suppliers. And another example which we'll show later is traffic management plan generation automatically. Now these allow cloud-based access to the capabilities which depend on or even sometimes augment this core enterprise network data. And at the same time, there's integration with external systems. And so these might be data coming in from external services and accessed on demand in order to provide reference data for the Data Gateway apps. So for example, we've got Data Ordnance Survey Data Hub in there. And these external systems might also be running the rules via the APIs or accessing either the core data or the dashboard statistics for analysis and insights. Now let's have a look at a real user view of submitting data. So I'm going to select the ecology survey project, and this is a project that we'll find out more about later on today. But for now, let's have a look at, for a user's view, what does that look like. So I've selected that project, and all I can do now is start a submission. And now it's asking me to supply data for this submission. So as a minimum, that's all I have to do is just drag data on there, have it accepted, and press go. So it's a very simple interface for users to use. When I continue, then that data is going to be uploaded to OneData Gateway, and it's going to first check the structure of the data. Is it in the right format, and does it have the right columns or attributes required? If, for example, I had a slightly different structure, so I might have a spreadsheet with different column names, then I can easily go in here, and without having to reconfigure the back end, I can simply tell the system what are the names of the columns in my particular spreadsheet. Okay, now I'm going to submit the data, and at this point the system is going to be running the automated rules to either accept or reject this data. So this use case here is, rather than exchanging files by sending by email or putting on a server somewhere, this is giving me a controlled way of accepting receiving the files, accepting them based on their level of data quality, and if acceptable, automatically ingesting that data into a central system. It makes it much easier for suppliers and for receivers. So if my data had a spatial location, I could view the results on the map, but this is telling me the results of all of these data quality checks that it's made. And as an administrator, as a receiver of the data, I can control thresholds to say whether that data level is acceptable or not acceptable based on my business needs. Okay, so now I'm going to continue to accept that submission, and what results in, once the data gets written back to the server, is I can now choose to, for example, view the report. And that report will give me that detailed information about my submission. It confirms the acceptance of that data. It gives me the results or the statistics on the results of my data submission. And if the data has been rejected, or if there were some things that had been flagged, I can choose to also download the resulting report, and that will give me information in detail about here are the records that failed and here is why they failed. So it makes it very transparent as a data submitter why my data has been accepted or my data has not been accepted. And as a person or as a user who's submitting data, I get to see the history of my submissions over time. And I can see the information in the project that an administrator may have been set up. And interestingly for me as well, I can see the history of my submissions. So like we saw with the administrator view, I can see which rules are causing me the biggest problems in my data. How many submissions have I made by day over time, and what's the conformance of my data quality over time, and I can drill down between specific dates. So what this does is it makes it very easy for me to submit my data. It's essentially it's fire and forget. If the data is sufficient quality, I send it in, it gets accepted. And it makes it much easier for the receiver of the data, because the data is automatically going to be ingested, transformed if required, validated, so I know that I'm receiving high quality data, I know when I'm receiving it, and it makes the whole process much smoother. So that was an example of using Data Gateway, but that was a very early stage in the asset lifecycle process. That was during construction of a network, submitting ecology reports. But Data Gateway is often used all the way through the project over the life of the assets as they're built and maintained and updated. Now let's have a look at another example, making use of those same networks that we talked about earlier. The networks that are updated, they can be useful in downstream processes. This example is traffic management plans. So every organization who needs to dig up the road has to submit a plan detailing what the signposts are going to be, what the traffic lights are going to be, according to a strict rule book. Here we're going to see how we can use that network information to automatically generate those plans based on applying rules based on the network. And that network information is very important because it tells us where the assets are, where the roads are, the road speed, the traffic conditions, and all these can be used to help construct a correct plan. Here's a user view of the traffic management plan automation application. This is what allows them to specify where they want to dig in the road to automatically generate a plan. So this is an example of a web map interface that we're using to create and define a plan. And first of all, to do this, we need information about the background network. So we're going to specify, for example, the location on the network, on the road network, where the plan is going to be created. We're going to give the plan a name. And then in order to create the plan, there's lots of information needed contextually about the area and the data. So some of this information, for example, the vehicle count over a 3-minute period, the HGV count, these in this case we're supplying them as user information, but all of these will also be, where information is available, automatically inferred from the network data. So now we need to define the work area, essentially where is the dig going to be happening. And from the information we've just supplied and this extent of the work area, that's all that's needed to generate the plan automatically. So we specify the work area size, and that's giving me now a summary of, okay, well, this is the information we're going to use to generate the plan, because each of these inputs are going to be required in order to calculate and to follow the rule book to generate the plan. So we're just going to generate a single work area here. Now, from that information, automatically the process that's running now is going to automatically generate the plan, and it's using all sorts of information. It's using, in this case, Ordnance Survey master map data, as well as highways data for the centre line, and then any other information about traffic counts, traffic volumes, cycleways, busways, if they're available, can be used to generate this. And so this shows the importance of having clean and correct network data, because it's enabling some of these downstream processes. Now that process is now complete, and it's generated automatically all of the signage for that's going to be used to generate the plan. So we can go in and have a look at that in a bit more detail. And so every work area needs to have appropriate signs, cones, traffic lights according to the traffic management plan rules. This is a fairly simple case. This is where we've got a road. It's a single carriageway road in both directions, with no trench on the pavement. One of the advantages of generating this information, which is going to be used to plot the plan, is that we can also generate an equipment report automatically. So here is the plan that's been generated. That's what's submitted to the local authority, but also the information about the assets required, the signs, the traffic lights, the inventory for that can be generated, and that saves huge amounts of effort, because the users who are going to lay out the traffic signs can know that explicitly before they go on site. And then finally, here's a view of that data in an augmented reality application. So we can see that actually people might be going on site and doing this remotely, and then they can very quickly see the outcome of those assets laid out, so that they can assess, yes, that's given me the right information, it's in the right place. What we've seen now is 1Spatial technology being used in a number of ways to help with network asset maintenance. And we've seen that being used in different parts of the life cycle. So right at the beginning during construction for ecology reports, or during the process of maintenance, either updating the network or also associating incidents or accidents or asset information against that network. And then also we've seen some of the downstream benefits of the network itself being used to generate traffic management plans. And these are all examples of using rules and automation to achieve location master data management. Thank you.
Thank you for your presentation. There's a couple of questions here. First one is, and again, just like to say thank you to Steve. That's a fantastic presentation. You mentioned, Seb, that one data gateway uses rules. Realistically, how hard is it to write these business rules?
Yeah, the business rules are implemented using the 1Integrate, which is the product that sits underneath Data Gateway. That uses a user interface to define the rules. So essentially, you need the best thing is someone who knows the data, they know what the requirements are, and they can use this user interface. It helps to have a logical mind, but the aim is you don't need developers to write the rules. You're not writing code. You're using user interface.
Okay, so it's UI created rules, no development. Okay, thank you. What else have we got? Okay, what are the deployment options for one data gateway? So will our IT team need to be involved in its deployment? And I don't know who's written that, so we haven't got any names on this one, but
there are a couple options. So one is you can have it deployed as a pure software as a service. So 1Spatial manages all of that. You just access it and use it. Some organizations choose to have it, they install it themselves. So they install it either on their site or remotely, in which case they can do that if they want to, but it's also available as a pure SaaS software.
Okay, thank you.